a 10 feet ladder is leaning against a wall. If the top of the ladder slides down the wall at a rate of 2 feet per second, how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall? Okay. Okay, here we have our situation here, and the ladder here is falling down, right, with a speed of 2 feet per second. But first, I want to denote here the distance from the wall until the bottom of the ladder here as x. So this is our x. And then the distance from the height of the ladder to the bottom of the wall here as y. Right, so this distance here is y. And we have the ladder here as z, and z is equal to 10 feet, right? Okay, so now what can we get from here? The top of the ladder slides down, so we have the rate of this part here falling down like this. And this is the change of y, right? So we will have dy dt. And what is dy dt? Dy dt here, according to the problem, is 2 feet per second. But then y is decreasing, right? Y is start from here and it's decreasing until eventually it reaches 0. So I will have the minus sign, and that will be minus 2 feet per second. And that is dy dt. And we are looking for how fast is the bottom moving along the ground. So we are looking for this speed here, which is the change of x with respect to time. But if this is falling, this will be increased, right? So we will have this as dx dt, the change of x with respect to time, and that should be a positive value. Okay. And then what else that we can have from here? We need to find out the relationship between x, y, and z. So we need to find out x, y, and z now. Okay, because this is a right angle triangle, the wall and the floor forming a right angle here, and the ladder is the hypotenuse, right? So we can just use the Pythagorean theorem. Let's exactly do that. So we will use Pythagorean theorem. Okay, we know that this x squared here plus y squared here is equal to 10, but this is squared. Or I can rewrite that as x squared plus y squared is equal to 100. And that is good because now we have the relationship between x, y, and some constant. But then we are looking for dx dt, and also we are given dy dt. So we need to take the derivative of this function here with respect to time, right? So to get dx dt and dy dt. So what we need to do is to use the implicit differentiation with respect to time. Okay. And here the differentiation bit of x squared is 2x. So we will have 2x, but that is the differentiation of x squared with respect to x. To get it with respect to t, we multiply this by dx dt. And we can apply that to this y squared, so we will have plus 2y. But this is the differentiation with respect to y. To get it with respect to t, we get it here, dy dt. And all of that will equal to 0. Okay, and we can cancel out this 2 here. Good, and all that we need to do is we isolate this dx dt, right? So what can we do now is to isolate that. So we will have dx dt here, dx dt. And that will equal to, I think we will have minus y over x, and then multiplied by dy dt. Good. And that is the equation that we need to save here to find out what is dx dt. Now the case is when the ladder is 5 feet from the wall. Okay, let's clean this up. Okay, now what we need to do is to plug in the values when the ladder is 5 feet from the wall. That means that x is equal to 5 feet. So when x is equal to 5. But then we also need the value of y here. dy dt, we know it. So the only unknown values here is the y. And how to get the y? We can just use the Pythagorean theorem, right? Because we know that x squared plus y squared here is equal to 10 squared. Or I can just plug in this x is equal to 5. So we will have 5 squared plus y squared is equal to 10 squared. Or I can have y squared here is equal to 10 squared is 100. And then minus 5 squared, that will be 25. Or y squared is equal to 75. Or I can get the y here is plus minus, but because this is a distance, it's always positive. So I will have the square root of 75. Or I can rewrite this as square root of 25 multiplied by 3. And so we will have our y here is equal to 5 square root of 3. Good. Now we know then when x is equal to 5, y is 5 square root of 3. We can just plug that in into this equation here. So we need to find out what is dx dt. dx dt when x is equal to 5. So we will have minus y. Y is 5 square root of 3. And then x is obviously 5. And then dy dt. So we'll have minus 2. Okay. And then what can we do from here? 5 and 5 will cancel each other into 1. And minus will become plus. And obviously we will have 2 square root of 3. And what is the unit? The unit of x here is feet. And the unit of time here is second. So here we have our final answer, which is 2 square root of 3. And that is the final answer for this problem. 2 square root of 3 feet per second. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.